Okay, we delayed the start of this class a little bit because I got knocked off of my other feed, and we're back. So, class has officially started. As with normal, in the event that something happens to this feed, I will record the class offline and I will post it on all the pages, on all the social media, okay? So if something happens and it dies, I will re-record and then I will post it live for everybody, okay? Next, I see all of you saying hello as you're logging in, and I appreciate that very much. But from this point forward, I won't be able to acknowledge you anymore, but know that I see it and I know that you're saying good morning to me, and I appreciate it. Let's start with the schedule. Tuesday, April 21st, all of these will be at the same time as this one. It's at 10 o'clock. We're doing ancient sea creatures. This is where I'm going to talk about megalodon. I'm going to talk about the mosasaurs and the plesiosaurs and the ichthyosaurs and some of the giant fish that existed. So that will be April 21st. Friday, April 24th, Dragons, Legends, and Myths. This is the class where I'm going to talk about how fossils may have led to the idea of mythological animals. There may have been things that people saw that they didn't realize it was a fossil of an animal. They thought it was something that had died recently, and that could be where some of these come from. April 28th, Dinosaur Mistakes and Errors. This is going to be a lot of fun. This one was recommended by my best friend, Alex. This was recommended because there's so many things that we see on TV and that we see in movies that are just completely inaccurate. And this will be the day that I will talk about some of those. And then finally, May 1st, I'm doing a class on pterosaurs. Those are the flying reptiles. So that is your upcoming schedule. These, of course, are free to absolutely everyone, and it will be a great way for you to learn about them. And I appreciate all of the suggestions for future ones. My hope is that I will continue to do these all the way through the end of the school year. So in May, I hope to be able to continue to do these. Now for one of the announcements that I need to make. We were going to begin offering live online lessons like the ones you've been seeing. We had planned on making those available in August because so many schools from around the country and the world want to have me come speak to their students, but they simply either couldn't afford to bring me all the way from Texas there, or I was so busy I didn't have time to visit them. But because of what's occurred, we have now bumped that up. So, starting immediately today, we are now offering private online lessons. Now, these lessons are not free. And I'm not going to stop doing the free lessons you've seen. So we're not switching now to where now you have to pay. That's not it. These are private online lessons that are going to be done through Zoom or Facebook Live. The normal fee would be $125. That would be our normal fee, and that's what we'll charge during the summer and for the rest of the year. But from now through May 31st, we will make them $50 each. There is a coupon code that you type in. It's just SALE. If you go to our website at dinosaurgeorge.com, you go to our catalog and you want a private lesson, when you click on it to order it, it's going to give you 6 different options of subjects. Or you can make your own topic that you would like to learn about. And then when you click that you want to order that, there's going to be a coupon code in the bottom left, and you type in the word sale, and it will change that $125 to $50. Now, again, these are not replacing the free classes I've been doing for you. You do not have to pay $50 to see my classes. All that this is if you want a private class where you can actually interact. So if you are a teacher and you have a group of students and your students want to ask questions, well, at the free courses, there's 500 or 600 or 700 people sending in questions, and I can answer them. So a private lesson would be an interactive lesson between you and the participants. If you are a homeschool parent and you have a homeschool group, it doesn't matter how many people are in it. It doesn't have to be one-on-one. So if your homeschool group says, we would like a lesson, but we want to be able to talk to you specifically, well, then what you would do is you would order it online. Once we get the order, we'll contact you. We'll find a date and time that works for you. We will then send you, if it's through Zoom, we will send you a password that only you can share with anybody you want, and they can all participate. If it's Facebook Live, then you would have to provide us with who the individuals are that you want to participate, and I will only make it visible to them. Again, this is only if you choose to do this and you want a private lesson between me and your child or your family or your group. These are 45 minutes long. I do 30 minutes of education and leave 15 minutes for Q&A, questions and answers. But if you want to change that up and you just want your kid just to talk the whole time and ask me questions, we can do that too. But for right now, through May 31st only, and let me say this, you cannot book this beyond May. So in other words, if you are a school and you're wanting to book it for next year, unfortunately, I cannot give you the $50 price to be good after the end of May. So these sessions have to occur between now and the end of May. And yes, your kids will be able to talk back and forth with me or your students during the Zoom portion. If we do Facebook, obviously it's just going to be messages. But through Zoom, yes, I will mute everybody's page when I'm speaking at first, and then I will unmute, or if your student has a question and they raise their hand and I see them, I can click on them, and yes, I can interact live with them. If it's a small group, just one or two people, I won't mute anybody. They can just interact throughout the entire class. So that is taking place now, and I hope it's something that you are interested in. If you are, then please use our services. But again, let me make it perfectly clear to everybody, it will not change anything about what you saw. For instance, there's the schedule. These are, you do not pay for these. These are completely free. And they are going to be for everybody, okay? For absolutely everybody. One last thing I want to cover. The 15% off on our catalog is still going on. If you order anything on our catalog, remember to use the code Dino George to get you your 15% off. That code will not work with the program I just talked about, the live video. If you put Dino George in that code, it's only going to take 15% off of $125. If you put sale, that one item will be dropped to $50. Okay? All right. Now let's get into rocks and minerals. Let's start with the three kinds of rocks. Rocks and minerals are not the same thing, and I'll explain that. First, we're going to talk about rocks. There are three kinds. There are sedimentary rocks, metamorphic rocks, and igneous rocks. Those are the names. Remember in other classes where I taught you how animals are put into family groups? Remember how we do that? We do the same thing with rocks. Rocks and minerals are put into family groups. And in our family, there is sedimentary, metamorphic, and igneous rocks. They are all different, and let's start with sedimentary rocks. Sedimentary rocks are caused by sediment. And what that is that's tiny grains of sand or rock that are layered on top of each other and then squeezed by pressure to form it into a rock. How does that work? Just like this. These are Smarties. Ooh, Smarties. Candy. Smarties, when they're made, used to be a powder. They were a powder. Sort of like sediment. But then using a machine that squeezes it, it turns it into a solid. Now, you can break it apart pretty easy. That doesn't mean you can eat sedimentary rocks, by the way. You shouldn't eat sedimentary rocks. But sedimentary rocks are formed by sediment that squeezes the rock together and turns it into a solid. Almost all fossils are found in sedimentary rock. Almost all fossils are found in sedimentary rock. And let me explain why we don't find them in metamorphic or igneous. Here's why. Metamorphic rock is a rock that is formed underground by a large amount of heat and pressure. Heat and pressure kind of squeezes them together, but it takes two different rocks and squeezes them into one. The heat and pressure way underneath the ground, there's a lot of heat and a lot of pressure under the ground. I'm talking about miles underground. And so that then kind of sort of melts the rocks together. And that's why when you look at this picture of metamorphic rock, you see the different colored lines in it. That's because unlike sedimentary rock that just squeezes it all into a lump, metamorphic rock uses heat and pressure. And that sort of melts it and makes it a much stronger bond. So metamorphic rock is stronger than sedimentary rock because of the way it's made. And then we have igneous rock. Igneous rock is a rock that is formed by lava or by magma. And there's a difference. Magma is what we call the molten rock when it's underground. Lava is what we call it when it comes on top of the ground. That's the only difference between them. So igneous rock is made by molten lava. And I would venture to say that you might have igneous rock in your yard. Some people use igneous rock. You know that black rock? It's just like I showed you in the picture. That black rock, that's igneous rock. So let's talk about some of the uses of these rocks because they're useful, right? All right. Did you know sedimentary rock was used to help build the pyramids? And sedimentary rock was used to help build the White House here in the United States. Sedimentary rock can be used to make all kinds of things. So that's a good example of how sedimentary rock is used. Metamorphic rock. Remember I said metamorphic rock was stronger? Was stronger? Metamorphic rock is very often used in construction. Like, for instance, if you ever walk along railroad tracks and you see all of that rock that they built the tracks on, that is a metamorphic rock. That's metamorphic rock. It is there so that it's there because it's so strong it will stand up to the weight of trains going by. So metamorphic rock can be used for construction, like our highways. Highways often use crushed metamorphic rock because it is stronger than sedimentary rock. Sedimentary rock isn't that strong. So you might say, well, then why did they use sedimentary rock to build the pyramids if it's not that strong? Some sedimentary rock is very, very strong, especially limestone. Limestone is a sedimentary rock that's made up by the tiny, tiny little animals that lived in the ocean. Little single-celled animals. They have a hard body made of calcium. Well, those little animals, when they die, they sink to the ocean floor and they piles and piles and piles. And over time, it's squeezed. Well, because of what their body is made of, it's way stronger than most other sedimentary rock. Like sandstone and mudstone are not very strong. You can break them apart with your hands. But limestone is different because of what it's made of. So the pyramids were made out of limestone because it was so incredibly strong. And then igneous rock. I will bet you a lot of you have igneous rock in your house right now. Because do you know that granite is an igneous rock? And granite is formed from volcanic activity. Granite is used for countertops in kitchens or in bathrooms. So I will bet you that within your homes, you may have examples of some different kinds of rocks. So here is your homework. Find something in or around your house that is made of rock. It doesn't matter what kind it is. If you can guess what kind of is, that would be better. But if you find something, I want you to go to the Dinosaur George Jr. Facebook page, and I want you to show a picture of what you found or tell me what you found. We love, love, love your pictures. We love them. So make sure for your homework to find something made of rock. And let me tell you one more fact about rock. And this is kind of cute. Do you know that your toothpaste has rocks in it? Let me say that again. Do you know your toothpaste have rocks in it? Yes. Toothpaste actually has very finely ground rock. That is used to help polish your teeth. Now, you cannot eat rocks outside. We can't do that. We get very sick. But they disinfect them and grind them into such a fine powder you can't even see them. But yes, even things like your toothpaste has rocks in it because that's something that's useful in our lives. We use rocks all the time. So remember, the three kind of rocks are sedimentary, metamorphic, and igneous. Now, at the beginning, I said rocks and minerals are different because they are. Let's talk about minerals. Minerals are the most beautiful things you'll ever see. Minerals are amazing. Minerals grow. Minerals grow. I know that sounds crazy, but they grow. The way they grow is minerals are made up of chemical compounds that attach to each other. And as more and more chemical compounds grow and attach, it makes the mineral larger and larger. Some of you, I know, have grown minerals at home as science experiments. Now, I do not have any information, but if you go online, right when this class is over, you can go online and you can Google grow minerals at home. And you can do a science experiment and you can do the very thing that happens in nature. You can grow your own minerals. By doing that, you're recreating what happens under the ground. And minerals are different. Minerals are absolutely beautiful, and there are over 4,000 different kinds of minerals. You want me to name them all? Here we go. Quartz, and then 3,999 that are not quartz. There, I named them all. Awesome. All right. Okay, so I don't know all 4,000, but minerals come in all shapes and sizes. Minerals can grow, and minerals look amazing. And one of the minerals that I find fascinating, of course, are geodes, and we're going to talk about those in a minute. But a geode is a mineral because inside there is quartz. Quartz is a mineral. So geodes have minerals inside. You know what else is a mineral? Iron pyrite. Fool's gold is a mineral. It's not an igneous, it's not a metamorphic, and it's not a sedimentary rock. It is a mineral, and that's different. And they actually grow and they form. Now, some minerals that you see are natural. Some that you see are dyed, and there's a difference between those as well. One of the most common natural minerals people love is amethyst. Amethyst is beautiful. It is something that grows inside of geodes, but it ends up having a purple color to it. There's another one called citrine. It's kind of an orange color. Fluorite can be green. Fluorite can be purple. Fluorite can be clear. So some colors you see are naturals, but others are dyed. And let me explain that to you. This is a natural quartz crystal that came out of the ground from Arkansas. It grew in the ground. Now, this is what it looks like naturally. But you can take quartz and change its color by dyeing it. This is purple quartz. It used to look exactly like this. This was this. This became this because it was dyed. It's still quartz. It's still real, but the color is not real. Now, they don't paint these. That's not how we do this. What we do is we heat these up to where they're very, very hot. And when you do, that makes weak spots inside. Then we drop the heated rock into dye, and it causes them to make little cracks, and the colored dye goes into the cracks. Then when we take it out, we wash off the outside. It looks purple, but it's not. That's the dye that's in the tiny little cracks that we created when we heated this up. That's how dyed quartz is made. We don't paint it. We don't put paint on it, because if we did, you could scratch it off. The reason why it doesn't come off is because it's in there. There is another thing called titanium electroplating. This is fascinating. We can take a piece of quartz, white quartz, plain everyday quartz. Scientists can then connect that quartz to electricity. How crazy is that? They run an electrical current through it. It's not hard. It's not an electrical current that can shock you and kill you. That's not like that. It's very light. But the electricity goes up into the quartz. Then they put that inside of a special, it's called a vacuum. It's a box where no air exists. And what happens is they pump in minerals, like metals, like titanium, or like they pump in gold. Well, what that does is that titanium or that gold attaches to the quartz. The electricity acts like a magnet and it attaches itself. It's not painted on. You cannot wash it off. It is electroplated, stuck to it forever. And that is how we end up with rocks that look like this. This is not a natural rock. This is quartz that has been electroplated. How nuts is that? And here's another one that they do with amethyst. This is fascinating. We call this aura. Get a load of this. This is called aura amethyst. This is where scientists have taken amethyst, put an electrical charge to it, put it in a vacuum, and then the dust of the titanium, or they have other chemicals, minerals that they use, or chemicals that they use. They dust that in, and that metallic dust is attracted to the rock and sticks to it forever. You cannot wash this off. You can't scratch it off. It's there forever unless you break it. So aura amethyst is a mineral that has been electroplated with things like titanium and gold dust. How cool is that? Isn't that amazing? So if you see that, then you're going to realize some rocks that you see are going to be natural colored and some are not. And back to this page, on this picture that I'm showing you, none of these rocks have been dyed. All of those rocks are natural. So there's natural beauty, and then there are those that are dyed. And now, let's talk about geodes, because that's the thing that everybody loves. First, let me explain how a geode is made. A geode is basically a rock. They're not all round. Some are different shapes. But here is what happens. The most common way. A geode can be formed when lava from a volcano cools, and there are holes in the lava that are made by bubbles of gas. It's a volcano burp. Bubbles of gas are trapped because the lava is too thick and the bubble of gas can't come out. So it just sits there. And then over millions of years, that gas bubble, over time, water finally makes its way into it. And water can get into that bubble. What happens is that starts the process of minerals that begin to grow inside of the bubble. Now, as the water comes down, it causes the outside of the bubble to become hard. It acts the same way fossils are formed. The same thing. It is dissolved minerals seep into the bubble, and the outer edge of the bubble becomes covered with rock. And as that rock seals itself, The water inside and the gas inside is used to start making geodes. Crystals begin to grow. You have rocks that form in bubbles of gas like this. Here you have lava, number one, lava that's come out of a volcano. In picture number 2, the bubbles of gas that are in that lava are still in it. Picture number 3 shows you where over time that lava becomes solid and the bubbles are trapped. Picture number 4 shows you how water can get into it and then some of that water and gas leaves. And picture number 5 then shows you how those crystals begin to grow inside of that rock. Now, it's not always from volcanoes. There's other ways geodes can form. For instance, when a tree dies and the roots rot and decompose, that can leave a hollow space under the ground where the root used to be, right? That can do the exact same thing. That's why sometimes geodes can be long, geodes can be round, and the reason why most of them are round is because bubbles are round, right? Bubbles are always round. Go outside and blow a bubble, it's round. It's not square, it's round. And so since the hole in the lava was round, the geode is going to take the shape of the bubble, right? So there are 2 kinds of geodes. There are hollow geodes that have crystals, but some of the crystals grow so much that they fill it to where it's solid, and that is called a nodule. A geode is hollow, a nodule is solid. So now, let's take a look at what it's like to break one of these open, okay? So now that we know how geodes are made, let's get cracking. Now, if you order geodes from us online, they're going to come in about this size. This is about the size that we sell. And geodes sometimes, well, we never know what's inside ever. We just don't know. But sometimes some of them are so filled with crystals, they're not hollow, they're just solid. Well, the ones that are hollow, I think, are better. So when we ship them to you, we try to weigh them to figure out, because if one's solid, it weighs more. So let me explain what I mean. This piece of equipment that I'm using, this is a tool that is designed to squeeze the rock, and that breaks it open. But that's not what most people have. So if you're going to break open your own geode, here's what you want to do. Lay a towel over the top of it. That's to keep pieces from flying off and hitting you in the eye. You don't want to do that. You lay a towel over the geode. You take an old screwdriver and set it right in the center. For you young people, get your parents to help you. Set the screwdriver in the center, take a hammer, hit it a couple of times, and it usually breaks open. Now again, I'm not going to do that. I'm going to use a tool that I have, because we crack sometimes thousands of geodes, and I just can't sit there and hammer all day long. So let me explain what this piece of equipment does. There's little blades, there's little cutting wheels on each one of these things. It's kind of hard to see. I can't twist it because it's solid, but see the little blades? Well, as I turn this handle, it squeezes the chain harder and harder until it breaks it. So let's see if we can break open first. This is a geode that was pretty heavy. I think it's going to be filled with crystals, but I want you to see what it looks like, okay? So let's put it in there. Let's begin to turn the crank to see if we can break this thing open. Hear it? Notice how, even though I'm wearing glasses, I still turn my head away, because you don't want it to hurt. Now, with this particular one, it's so hard to break open. I'm going to have to use leverage. So I add this. There we go. So now, let me loosen that. Let's see what's inside of this geode. Ah, it's what I expected. See, it's solid. It's completely solid. Still beautiful. I still think it's beautiful. I mean, this is amazing. It used to be one solid piece of rock, but broken open, it's solid crystals. Now, let's see if I found a better one that was much lighter. I think this one might be hollow. So let's take a look. Again, there's no way I know. I cannot know what's inside of these rocks. I can only guess, and I can use my best judgment. So let's see if we can crack this one open. Feel it getting tight. That one broke easily. You know what that means? That means it's probably hollow. So let's take a look. Aha! It is! Look. There we have it. Used to be a solid rock, but it has crystals inside. Now, for fun, we're going to break open a big one. Now, these big ones, I don't sell these online because we break them all ourselves and we sell each half. So you can get them, but they're boxed and they're usually dyed. See, some people don't like the look of the outside. They think it looks too plain. So we soak them in a dye and it changes the color of the outside. It doesn't change the color of the crystal inside. It just changes the color outside. So let's try a big one and let's see what we can do here. This is a big one. Chain goes around. Chain connects. Try to put it in the middle. Give it the old squeeze. I can feel it squeezing right now. Oh, that sounded like it broke. Now, here's the greatest part about geodes. No human has ever seen inside of this rock. None of us know what's in it. When you break open a geode, you are the first person in the history of the world that has ever seen inside. So of all the billions of people, you are the first to see inside. Well, let's take a look at this one. Now, I'm not going to look inside first. I'm going to turn my head. I want you to be the first person to ever see inside. Here we go. Look at that. Used to be a solid rock. Now it is absolutely magnificent, filled with crystals, and you were the first people in the history of the world to see inside. So that's what it's like to break open geodes. All right, I don't know whether or not any of you were able to watch that video because, again, my message is saying that the video was not working. And so if that is indeed the case, when this is done, I'm just going to go load just that video onto my page so that you guys can see it. So in the event that you weren't able to see it, at least from my end, it's saying that the video was not being shown. I don't know, but hopefully you guys all saw that. All right. So in the event that you didn't see it, like I said, I'm just going to go jump on and I'm going to post just that video. Okay, you did see it, Blake. Jennifer, good. Okay, so you saw the very end, right? The big geode that was broken open. So good, that's great news. So mine is saying that it didn't work. All right, well, I'm very glad to hear that because I had hated to think that you didn't get to see that. And how cool was that? You guys were literally the first people in the world that ever saw inside of that geode. Now, obviously, after this video airs, a lot of people are going to see it. But you today would have been the very first ones. So remember, there was two kinds of geodes that I broke open there. There was a geode and there was a nodule, right? And those are two different things, right? So if you ever get a geode and you break it open, if there's nothing inside, if it's solid, there's nothing wrong with it. It just means that it is solid, that the crystals continued to grow so much that they filled it. Now, something else can happen as well with geodes. Sometimes the water never completely evaporated, or sometimes there was a hole in the geode when it formed. If that geode has water in it, or if the geode had a hole in it while it was forming, the crystals will not form very well. If you ever buy a geode from me and you break it open and it's yucky inside, like it's just kind of dirt, and that means that there was a hole in it. And you let me know if that ever happens, because we do everything we can. Sometimes I can pick them up and look at them to make sure there's not a hole in it. If I see a hole, we throw them away because those are just not going to be any good. But if you ever get one like that, the only thing that happened was it never sealed itself completely and it was allowing air to penetrate, and crystals don't want anything in there. Crystals need complete darkness and to be protected from anything, and that is how they grow. So for those of you that are interested, we put our geodes, we put them on sale but you still get your 15% discount off of the sale price. So if you go on and you order them, remember when you order them, the code is Dino George, and if you enter that, it'll take 15% off. Also, let me cover this one more time because I know some of you were confused. I was looking at some of the comments. If you are interested, you can get your own private online lessons. The cost between now and the end of May, if you enter the coupon code SALE, the normal price of $125 will be reduced to $50. You can have as many people on it as you want. Yes, this is interactive for you only. If you do it through Zoom, I can talk to you and you can talk to me. So if you have questions, we can do that. If it is for a classroom, then what I will do is I will mute everybody's microphone until I'm done. And if you have a question, you can raise your hand and I can call on you that way. But we'll work through all of that stuff. But I'm going to continue to do these free courses for everybody. And I hope to be able to do them all the way through the end of May. But for right now, here is your schedule for upcoming events. And they all start at the same time as this, 10 o'clock. And that is it. Sunday, this coming Sunday the 19th, we're making another very big announcement. And then next week, we're making another announcement. All of this stuff is really cool. The one we're making, the announcement we're making for next week is going to be about some clubs that you can join. Very cool. The one for Sunday, wait and see for that one. It's going to be great. So with that, take care of yourselves and take care of the people around you. Class is now over. I will hang around and answer questions. Thank you all very, very much for doing this. And I hope that you guys enjoyed this lesson.